modern term definition of oxidation and reduction reaction. In modern terms, but we first of all give the definition based on transfer of electron. Oxidation is defined as a process by which the valency of an element is increased, while reduction is defined as a process whereby the valency of an element is decreased. Don't forget that both of them are opposite of each other. So if you check the definition now, you see that oxidation involves increasing oxidation number or valency of an element, where reduction involves decreasing oxidation number or valency of an element. From the example on the board, if you check A, you see ion 2 ion going to ion 3 ion. If you check the oxidation state, it changes from +2 to +3, which is an increase. Remember, oxidation is a process involving an increase in oxidation number of an element. So if you watch, that ion from the left-hand side has changed from +2 oxidation state to +3 oxidation state. It's a clear, good example of oxidation reaction. Where the example 2 there, copper 1 ion has changed to copper 2 ion. If you check it very well, from +1 to +2 is an increase. It's an increase. So in example A1 and 2, both of them are examples of oxidation reaction. Just take note, an increase in oxidation number of an element is called oxidation reaction. All right, check example 2 or be part of it there. If you watch from that place now, you see sulfur. A sulfur atom changes to sulfide ion. And the oxidation state of that sulfur atom from the left-hand side is 0. It is changing to -2. If you watch, 0 to -2, if I may ask you, is it an increase or a decrease? And of which you know, it's a decrease. 0 is bigger. 0 is bigger than -1 million. So it's a decrease. So example B is a reduction reaction in the sense that the oxidation number of that sulfur atom is decreasing. Don't forget, 0 is bigger than minus anything you can ever imagine. So something moving from 0 to minus is a very big loss. It's even better that you are at a 0 point than you are at a minus point. So it's a reduction reaction. So having noted that, this one is now going to lead us to the modern definition of oxidation and reduction reaction. Let me show you an example on the board. So from here now, you have seen the modern definition of oxidation and reduction reaction. Oxidation is a process involving the loss of electrons. Reduction is a process involving the gain of electrons. That X is in bracket. It could be 1 electron, it could be more than 1. So don't forget all the definitions we have exhausted so far, but try to relate this modern definition to the last one we just discussed now. Oxidation is a process involving the increase in the oxidation number of an element. If you compare that one with this modern one now, it will look as if it is confusing. How can a substance which is increasing in its oxidation number be losing electron? Remember, compare the last definition in terms of electron transfer and now this modern definition. It looks as if they are contradicting, but I am going to give you a proof that when an element has its oxidation number increasing, actually it is losing electron. It may sound funny, but let us see how it goes. And when you see an element decreasing in its oxidation number, it is gaining electrons. Let me show you illustration on the board. Let's check this. Don't forget that ion which I used before. If you see that ion from +2 oxidation state is changing to +3 oxidation state. So if you watch carefully now, you see that ion, the atomic number of ion is 26. And don't forget that an atom has the same number of protons and the same number of electrons. So if you watch, if you know chemistry very well, this is cation. This plus 2 ion means that ion has lost 2 electrons. Ion has lost 2 electrons. And changing to plus 3 oxidation state, ion has lost 3 electrons. That is positive. If you have anything cation, any element cation, it means that thing has lost electron. So ion having 26 electron in this plus 2 oxidation state loses 2 electrons. So 26 electron of this particular ion minus 2 electron it has lost. The electron remaining for this ion 2 here is 24 electrons. 24 electrons is what is remaining for ion 2 ion here. Now, going to ion 3 now, 26 electron minus 3 is 23 electron left for ion 3 ion. So if you compare it now, ion 2 ion has 24 electrons, ion 3 ion has 23 electrons. So if you check it, from ion 2 to ion 3, 1 electron has been lost. That is that thing I was telling you, that actually, when an element has its oxidation number increasing, actually it is losing electrons. You can check it very well here. Ion 2 has 24 electrons. But when it goes to ion 3, it has 23 electrons. But if you check it from the other side, the oxidation number is increasing plus 2 to plus 3. But the electrons is decreasing. So when the oxidation number of an element is increasing, actually it is losing electrons. The same way with copper, the atomic number of copper is 29. Is 29. So here now, copper has lost 1 electron here. 29 minus 1 gives you 28 electrons. Going to copper 2, it has lost 2 electrons here. Just mind you that this is another part of the equation. Just compare what you have here and compare what you have here. This is the reactant. This is the product. Compare what you have here and compare what you have here. That is when you really know the difference. Now, ion 2 ion, copper 2 ion has lost 2 electrons. So in copper 1, you have 28 electrons left for copper 1 and the 27 electrons left for copper 2. So if you watch it, it is somehow dicey. But just mind you that when the oxidation number of an element is increasing, actually it is losing electrons. It is losing electrons. This is oxidation reaction. So this one has justified that definition that states that oxidation is the process involving the loss of electron. At least this modern definition has compared definition in terms of transfer of electron and now the modern definition. Let me now show you an example for reduction reaction. Quickly, let's take that of reduction reaction. I'm still sticking to the examples I cited before. Sulfur. If you watch now, sulfur atom is 16. The atomic number is 16, which means it has 16 electrons. So that sulfur atom, 0 oxidation state, 16 minus 0, the 16 electrons is still intact. Now, going to sulfide ion, if you watch what I did before, in that ion, I did minus. Do you understand? But in chemistry, positive ion means losing. Negative ion means accepting, which means this minus 2 means that sulfur has accepted 2 electrons. Comparing with the first one I did, ion 2, 2 plus, lost. But this one, sulfur, 2 minus, accepted. Negative means acceptance. Positive means donating or losing. So that is it. So if you watch now in sulfur atom, the 16 electron is still intact. Moving now to sulfide ion, extra 2 electrons has been added to the 16 already sulfur has, making it 18 electrons. But don't forget that moving from 0 to minus 2 is a decrease, which means that decrease is actually getting electron. When the oxidation number of an element is decreasing, it is actually gaining electrons. As you can see here, sulfur atom has 16 electrons, sulfide ion has 18 electrons. So that is a very good example of modern definition of oxidation and reduction reaction. In the other way, oxidizing agent is an electron acceptor, reducing agent is an electron donor, which we will dive into in our next video. See you.